last session, we have discussed about valency and variable valency in metals. Today, we will discuss about variable valency in non-metals. Non-metals means maybe nitrogen, phosphorus, sulfur, like these atoms. So here, variable valency in non-metals depends on electron configuration and excitation of electrons from s orbital to any vacant d orbital, otherwise vacant p orbital if possible, or vacant f orbital also if possible. See, for example, here first I am writing statement related to this variable valency of non-metal. Variable valency of non-metal is due to excitation of electrons. Excitation of electrons from s orbital to d orbital or f orbital if possible. Most of the cases enter into d orbital. Here s orbital either from p orbital also we can consider. From p orbital also we can consider. Here we can write excitation of electrons from s orbital or p orbital to d orbital or f orbital sometimes, but it should be vacant. D orbitals or f orbitals should be vacant. Variable valency of nonmetal is due to excitation of electrons from s orbital, filled s orbital or filled p orbital to vacant d orbital or f orbital. So this is the reason how they'll show variable valency. See, for example, here I am taking nitrogen. Nitrogen will not show any variable valency. Here nitrogen 7 atomic number. Electron configuration is 1s2, 2s2, 2p3. So this is the outer shell. In outer shell, in s orbital 2 electrons are present. In p orbital, 3 p orbitals we have px, py, pz, 1, 2, 3. For nitrogen, no excitation is possible. No excitation of electrons is possible. Why no excitation is possible? Because here there is no vacant d orbital. See here there is a filled s orbital. 2s orbital is filled. So to excite electron from s orbital to other vacant orbital means that here there should be one vacant orbital. Here there is no any vacant orbital. So that excitation is not possible for nitrogen. Excitation is not possible means here its valency is with respect to these unpaired electrons, and when nitrogen donates this electron pair to other compounds which are having vacant orbitals means with respect to this it can, with respect not due to excitation of electrons. So here due to these three unpaired electrons in ground state, this electron configuration is called as ground state. Ground state electron configuration. In ground state electron configuration, valency of nitrogen, valency of nitrogen is 3. Direct bond it is, direct covalent bond. If electron pair, this electron pair is donated to vacant orbitals vacant orbitals of other species, then valency it can be, means valence can be 4. Then valency of nitrogen should be equal to how much? 4. So with respect to this 1, 2, 3, by donating this electron pair, it is a coordinate covalent bond. These three are direct covalent bonds. So in this way we can expect 4 also for nitrogen. Not direct, not due to excitation of electrons. Next, here I am taking one more example. It is phosphorus I am taking. Here atomic number is 15. For 15 electron configuration, we can write for 15 electrons, we can write electron configuration like this: neon, then 3s2, 3p3, and here 3d orbital also present with 0 electrons. With 0 electrons, because third shell is present means third s orbital, third p orbital, and third d orbital also present. But here 3s2, 3p3 are written. About 3d are written here 0 electrons means it is vacant. So we can write in this way. Here 2 electrons are present in s orbital, in p orbital. Here 1, 2, 3. D orbital is vacant here. In d orbital no electrons are present. All these are vacant. This is called as ground state configuration. Ground state electron configuration. In ground state, here valency of phosphorus. Here valency of phosphorus equal to 3. Here 1, 2, 3 in ground state. Then there is a possibility for first one excitation. Whenever this phosphorus approaches to other atoms or other species to form bond, due to those attractions, it can release some energy. That energy is utilized by this electron pair, and it split into single electrons, and one electron jump from here to this vacant d orbital. S orbital electron pair splits and becomes single electrons. The single electron enter into this. This means here it is vacant d orbital. That is called as first excited state. Here I am writing first excited state. In first excited state, see here I am writing one electron. Here as it is, 3 electrons are present. This electron now jumps from s orbital to d orbital. See now, how many unpaired electrons are present? 1, 2, 3, 4, 5. So that here, what is the valency? Here, valency of phosphorus is 5. 1, 2, 3, 4, 5. 5 unpaired electrons are present, so that we can say here valency of phosphorus is 5 due to presence of 5 unpaired electrons. Here due to presence of 3 unpaired electrons, valency in ground state is 3 for phosphorus. So like this it can show 2 valencies. Showing otherwise exhibiting more than one valency is nothing but variable valency. Variable valency in nonmetals is due to excitation of electrons from s orbital or p orbital to vacant d orbital. In few cases we can expect f orbital, but very rare. Okay, this is one example. Then I am taking one more example here, that is oxygen. Oxygen, then below that we have sulfur, the same group. First we will discuss about oxygen. In ground state and in excited state. Excited state is possible or not, we have to check here. Here I am taking example, that is oxygen. Atomic number 8. So here helium 1s2, then 2s2, 2p4. Total 8 electrons are there, no? Here 4 plus 2, 6 in helium configuration 2. Total 8 electrons. Here also no d orbital. Here no d orbital in configuration. Why means only 2 shells are present. In second shell there is no d orbital. Second shell contain only s and p, so no d orbital. So that there is no excitation here. So this is ground state. In ground state I am writing direct box configuration. Ground state configuration, ground state electron configuration. Here s orbital 2 electrons are present, p orbital here 1, 2, 3, 4. 1, 2, 3, 4 electrons are present here. But here one pair, this is another pair, 1, 2. These are the 2 single electrons which can participate in the bonding. So that in this ground state, valency of oxygen equal to 2. Valency of oxygen equal to 2. Combining capacity of oxygen equal to 2. Rarely it may donate to other substances, like hydronium ion is there. But donation of two electron pairs are not possible for oxygen, because oxygen is a more and more electronegative atom, you know. Being more electronegative atom, it cannot accept positive charge, because after donating this electron pair to other substances, at oxygen electron density decreases. Due to decrease in electron density, it will get a positive charge. Positive charge is not accepted by oxygen because of its more and more electronegativity. So that two electron pair, donation of two electron pairs are not possible. Two coordinate covalent bonds are not possible. So that here valency of oxygen is 2. Rarely in case coordinate covalent bond if participated, coordinate covalent bond is present, then we can go for 3 for oxygen. Hydronium and H3O plus example is there. H3O plus means oxygen, here hydrogen, here hydrogen. One more one more electron here, one more hydrogen is bonded with oxygen by accepting electron pair from oxygen. So because of donating this electron pair, oxygen will take positive charge. So it is very very unstable. So that one more electron pair is not possible to participate in coordinate covalent bond. In this case it is 3. Oxygen valency is 3. In almost the remaining all cases it is 2 only. But below this we have one more atom in the same family, sulfur, that is. Atomic number is 16. So here also I am writing electron configuration by taking neon 10 electrons, then 3s2, 3p, 6, 3s2, 3p, 4, and 3d orbital also present, but 0. Ground state configuration, ground state electron configuration I am writing here. Ground state. In ground state here s orbital, 3s orbital contain 2 electrons, 3p orbital, px, py, pz, 1, 2, 3, 4 electrons, here d orbital, vacant d orbital, vacant d orbital. See, in ground state, valency of sulfur, here valency of sulfur equal to how much? 2 only, like oxygen, because only 2 single electrons are present, only 2 unpaired electrons are present. Therefore valency of sulfur here is 2. Valency of sulfur here is 2 in ground state. But it may participate in different excited state. Whenever this sulfur approaches to other species to form bond, there should be some attraction takes place. Due to that attraction, some energy will be released. That energy is utilized by these electron pairs. So when energy is absorbed by this electron pair, it splits into single electrons. One of the electron jump to d orbital. Like that, how many pairs are there? That many excitations are possible. Here, with respect to this one electron pair, first excited state is possible. With respect to this one, second excited state also possible. For phosphorus, earlier just now we have discussed. For phosphorus, one is ground state, other one is first excited state. Only two. Ground state, first excited state. Here, along with ground state, we have two more. First one is first excited state. First excited state. Here, this electron pair remains as, and in p orbital, no. Total how many electrons? For one electron pair and two single electrons. Here, this electron pair splits and enter into d orbital. Here it is. So you can observe now how many single electrons or unpaired electrons are present. 1, 2, 3, 4. 4 single electrons means here valency with respect to single electrons here is 4. In first excited state, it can form 4 bonds. Combining capacity of sulfur in first excited state is 4. So it is now showing more than one oxygen state. One is more than one valency. One is 2, other one is 4. So it is showing variable valency. Here one more valency also possible in second excited state. In second excited state, this electron pair also splits and one electron jump from s orbital to d orbital, vacant d orbital. Already in d orbital we have one electron. Now this electron pair jump from here to here. See how many unpaired electrons are present here. 1, 2, 3, 4, 5, 6. So that here valency of sulfur Valency of sulfur here is 6. That is, it is showing 3 valencies. Showing more than one valency is nothing but variable valence. In this way, non-metal can show variable valencies. That showing variable valencies due to what? Excitation of electrons from s orbital or p orbital to d orbital. In this way, they can show variable valencies. First excited state or second excited state, even we have third excited state. For example, some xenon compounds we have. In xenon, otherwise inert gases. Inert gases also sometimes participate in the bonding, special cases. Because of that reason only, we can say noble gases. Particularly in specific conditions with specific particular atoms, even xenon like inert gases also participate in the bonding. For xenon, we have different excited states. Only here for giving different examples with respect to variable valency, I am taking xenon here. Xenon, it is inert gas. Atomic number, it is 54. Among inert gases, noble gases, there is 18th group elements, xenon can form compounds due to its very large size and very low ionization potential and more electropositivity. It can form bonds with more electronegative elements like fluorine or oxygen. So, how many bonds it can form? Xenon, one more example I am taking here. Here 54, and here electron configuration I am taking 5s2, 5p, 6, and here 5d, 0 we can write. Otherwise, here for inert gases we can write ns2, np6, no, octet configuration. Here nd, 0. So ground state configuration. First I am taking ground state. In ground state, here 2 electrons we can write here in s orbital. This is the p orbital. 1, 2, 3, 4, 5, 6. Here d orbital is vacant now. D orbital is vacant. See here, this is ground state. In ground state, how many bonds it can form? What is the combining capacity of xenon, or what is the valency of xenon in ground state? In ground state, valency is 0 here. Valency of xenon is 0. Why it is 0? Because no single electrons. Always combining capacity. Otherwise, in any bond, that bond formation must be takes place if unpaired electrons are present. Single electrons if present, we can expect one covalent bond or two covalent bonds or three covalent bonds, whatever it may be, based on number of valence electrons. So a covalent bond is formed due to presence of single electron. Sometimes paired electrons if present, then maybe it is coordinate covalent bond. It is not sharing. Means after donating that electron pair, it may share. In chemical bonding chapter, you can get clarity. Here, in this ground state, xenon atom has no unpaired electrons, no single electrons, so that valence is 0. Valency here is 0. In periodic table, again we will discuss about valency. For some formulas are there as per group number. Valency equal to its group number for first and second group, third and fourth. Valency equal to 8 minus group number, otherwise 18 minus group number for 15th, 16th, 17th and 18th group elements. 18 minus 18 for 0 group elements, 0 group means what? Combining capacity of those elements are 0. 0 valent atoms or nothing but 18th group elements. So valency of 18th group element is 18 minus 18 equal to 0. Means group number, otherwise 18 minus group number is nothing but valency. For that we have some formulas. There again we will discuss clarity. This is only basic. So how to get different valencies, I am giving explanation here. So in ground state for xenon, no valency, 0. In first excited state, take first excited state. This electron pair shift from here to here. This is as it is s electron pair. but one of the p electron pairs here 1, 2, 3, 4, 5. This sixth electron is there, no? That electron jump from this p orbital to d orbital. Now you can observe how many unpaired electrons are present. Here two unpaired electrons are present in this first excited state. So here valency equal to 2 for xenon in first excited state. Directly they may ask questions. In second excited state, what is the valency of so and so compound or element? Here for if it is xenon in first excited state, valency is 2. Here I am writing second excited state now. Second excited state. In second excited state, here same thing, 2 electrons. Here 1, 2, 3, 4, 1 electron jump from s orbital to d orbital, p orbital to d orbital. This electron will also now jump from here to here. Now how many? 1, 2, 3, 4. So that here valency is how many? How many unpaired electrons are present? That many. 4 now. Similarly, here we have third excited state also. Third excited state. In third excited state, this electron pair remains as, and electron jump from p orbital here. This electron jump from p orbital to d orbital. 1, 2, 3. Now how many unpaired electrons? 1, 2, 3, 4, 5, 6. Here V, otherwise valency, is equal to 6. Here fourth excited state also possible. Fourth excited state here. Fourth excited state. In fourth excited state, this s electron pair also jump from s orbital to d orbital. Here 1, 2, 3, 4. See 1, 2, 3, 4, 5, 6, 7, 8. Total 8 here. 8 unpaired electrons are present. So that here valency is 8. Combining capacity is 8. So like this we can expect different valencies, variable valencies. So for non-metals, it is due to what? Excitation of electrons. So no excitation here. Ground state means direct configuration. First excited state means what? By absorbing some energy. If one electron pair splits, first electron pair splits, then we can say first excited. One more electron pair also present. If that electron pair also excited, then that is second excited state. Like that third excited, fourth excited. For xenon, maximum excited states are how many? 4. In fourth excited state, how many unpaired electrons are present? That is the valency. Like this, we can expect valency of non-metals. Then about ions. What is ion? Ion is nothing but charged species. The charged species is formed by losing electrons, otherwise gaining electrons. Otherwise losing or gaining electrons. See here writing ions. Ions. How ions are formed? Charged species which are formed by losing or gaining of electrons is known as ions. They may contain positive charge, they may contain negative charge, they may be single atoms, otherwise that may be group of atoms. Charged, these are the ions are nothing but what? These are charged species. Charged species formed by losing electrons or gaining electrons. Losing electrons or gaining electrons. Simply, this is enough. Charged species formed, these are formed by losing electrons or gaining electrons, which are called as ions. So losing electrons or gaining electrons due to what? Why they are losing? To attain stability. To attain stability. Stability means what? To attain NS2 NP6 configuration. To attain NS2 NP6 configuration, otherwise octet configuration, otherwise completely filled configuration or closed shell configuration. As to get closed shell configuration, the particular atom may lose or gain electrons. If electrons are more, then they can lose. Electrons are less, they can accept. So gaining of electrons or losing of electrons is the reason for getting charges. Here these charged species may be single, anions may be cations, these may be single atoms or group of atoms. Means simple ions we have, then compound ions also we have. First of all, types of ions. Types of ions means cations and anions. Cations are nothing but what? Positive charged ions. Positive charged ions formed by losing electrons. About this already we have discussed. Anion is nothing but what? The negative charged ions. Negative charged ions. Here write ion. Ions formed by gaining electrons. Gaining electrons. Here we have different examples. This cations otherwise called. We have different examples for these. Cations maybe like Na plus ion. Example I am writing Ag plus ion or Ca plus 2 ion. Different ions are present. So simply I am writing M plus ion. Generally these ions are formed by bases. For example, base sodium hydroxide. Sodium hydroxide. After losing OH minus ion from this, OH minus ion, we get Na plus. Generally, cations are formed by bases. So that cations otherwise called as what? Basic radicals. Basic radicals. Similarly, anions. Anions means Cl minus or SO4 minus 2 or NO3 minus. These different ions we have. O minus 2 oxide ion, S minus 2 sulfide ion, N minus 3 nitride ion. These many ions we have. So generally these are found by acids. See for example if you take HCl, HCl it is acid. After losing H plus ion, we'll get Cl minus. Cl minus is formed from this negative ion, otherwise anion, which is formed from acid. So that generally anions are called as acidic radicals. Acidic radicals. Remember these terms. Cations and anions. Charges species are nothing but cations and anions. We can classify these ions into two types first. Cations and anions. Cations are nothing but positively charged ions formed by losing electrons. Anions are nothing but negatively charged ions which are formed by gaining electrons. Example are written here. But one more name is basic radical for cations, acidic radical for anions. Why it is so means generally all positive ions are formed by bases, alkalis. So that they are called as basic radicals. Anions are formed by acids. So that we can say they are acidic radicals. So we have one more classification. These cations and anions, but this charged species again classified into simple ions, then compound ions. Simple ions, then compound ions. Simple ions may be anions or cations, but they must be only single atom. Single atom is present there. So here simple ion may be Na plus, maybe F minus or N minus 3 or O minus 2. Any like this ion, simple ion. Only one atom is present. That above that atom we have positive charge or negative charge. That negative charge or positive charge may be 1 or 2 or 3. It may be any charge. Here Ag plus copper plus 2, Ag plus Cu plus 2, like this. Compound ions means they are the combination of atoms. Group of atoms are present in these compound ions. These are the ions which contain two or more atoms of different elements. Means example here, just now here written SO4 minus 2. It is sulfate ion. NO3 minus. It is nitrate ion. Like that we have like ammonium ion, hydronium ion, NH4 plus, ammonium ion. This compound, see here in this ion, here one sulfur, four oxygens. In this nitrate ion, one nitrogen, three oxygens. Here nitrogen, four hydrogens along with positive charge. Like this, you have different types of ions. If you know the types of ions along with their charges, then it is easy to write formulas. In next classes, what is chemical formula? How to write that chemical formula by using these concepts, it is by using these ions and their charges. And how we can get these simple ions and also compound ions also we'll discuss in next sessions. Okay, to that please be safe at your home. Thank you.